Hi, good afternoon, Professor. My name is Bodi Tan. My student ID is BT2484. Today I'm gonna do my final report, which is managing supply chain and its security. Here is a table of contents that I'm gonna go through today. I will start with introduction, then background, the concept development stage, um, engineering development stage, then post-development stage. After that, I will go through system engineering challenges of the program. And the last step, I will summarize the knowledge that I learned from this lesson and project. So what is supply chain? The supply chain is a system of organizations, people, activities, information, and resources involved in the process of moving products or services from suppliers to customers. What is supply chain management? In order to maximize the use of resources involved in supply chain, improve the efficiency of entire supply chain, and make the company more competitive. Here is a classic case. It's about Walmart and its barcode. Um, so the Walmart adopted barcode scanning technology in the 1980s. The barcode scanning machine is very light. People can do it with one hand. The barcode scanning machine allows Walmart to track inventory and streamline the payment process. The barcode is a visual representation of data, typically in the form of parallel lines of varying width and spaces, which represent binary code. Barcode scanner uses light to read barcode. Light sources illuminates the barcode, and a sensor detects the reflected light. The scanner's sensor converts the reflected light into an electrical signal. The pattern of signal corresponds to the pattern of barcode, which the barcode then interprets. When staff scan the barcode using barcode scan machine, the electrical signals generated by reflected light are processed by scanner's internal circuitry. The signal is then digitized, converting the variations in the signal into binary code. The digitized code is matched against a database to decode the information such as product identification, pricing, or inventory data. Before we start develop our system, uh, we should go through the concept development stage. So in this stage, we need to consider needs analysis, concept exploration, and concept definition. So for needs analysis, we need the real-time data and the data visualization. After we got data, of course, we need to do analysis, predictions, and recommendations. Then we should consider cross-functional workflow or orchestration. Then for the safety, we should implement or consider to implement blockchain-backed immutability and trust. Of course, we need to consider solution scalability because we need to improve our project in the future, right? So, okay, let's go through the real-time data. For real-time data, in today's complex supply chain environment, real-time data is critical to managing and optimizing operations to ensure transparency at every stage, from supplier to customer. The supply chain must have the ability to monitor the entire supply chain network. Real-time data helps to find and identify critical issues in a timely manner so that problems can be resolved in a timely manner. Real-time data enables supply chain managers to make informed decisions quickly, improving overall efficiency and responsiveness. By leveraging real-time data, companies can more quickly adjust inventory levels and monitor changes in demand for goods, enabling more flexibility and resilient supply chain. Visualization helps to quick locate and to resolve critical issues. Advanced data analytics and actionable workflows enable supply chain manager to make informed decisions quickly, thereby improving the overall efficiency and reliability of the supply chain. Um, Next, we need to consider data visualization. Effective visualization of supply chain data is essential for customers and suppliers to understand and manage complex operations. Easy to understand dashboards provides a comprehensive view of entire supply chain, highlighting key metrics and performance indicators. Visualizing data helps quickly identify patterns, trends, and anomalies for forward-looking decision making. Data visualization facilitates the exchange of insight across the organization, ensuring that all workers have a clear understanding of supply chain performance. By leveraging visual data, uh, companies can further leverage that data for analysis to achieve more complex solutions. Once real data is available, the ability to perform calculations on that data to generate actionable, predictive, and recommendations is critical to effective supply chain management. Using advanced analytics, companies can more clear interpret data from a variety of sources to customers and suppliers to anticipate potential problems and opportunities by integrating forecasts and recommendations into a, a field interface. Manager can act quickly and accurately to minimize risk and make recommendations for optimization. This approach not only helps manage current operations, but also helps plan for future development, allowing the company to minimize potential risks and make the company's operations more stable. Uh, for cross-functional workflow orchestration, as supply chain become larger and more complex, in order to copy with complex supply chain management, I can fragment, decentralize, and independent supply chain management to play a decoupling role. Cross-functional workflow orchestration ensures that different parts of supply chain work seamlessly together, enhancing coordination and efficiency, and avoiding problems where one part of process going wrong so that other parts don't work as well. This technology synergy allows for better allocation of resources, timely location and response to issues, and improved overall supply chain performance. Blockchain technology provides a secure and transparent way to manage data sharing with the supply chain. By leveraging blockchain platform, companies can strengthen trust and collaboration with suppliers. The immutability of blockchain ensures that data cannot be tampered with, providing security for transactions and product movements. This trust fosters relationships between suppliers and customers and is critical to creating a more reliable and secure supply chain ecosystem. So supplier may come from different regions, produce different goods, and serve different people. So in order to work with more suppliers and customers, the supply chain must be scalable. The scalability of solution allows companies to scale and personalize their supply chain solutions to different suppliers or customers, gain new insight, and automating operations through custom data processing, analytics, dashboards, and work queues. This flexibility allows companies to tailor their supply chain management system to their specific needs, ensuring they can respond quickly to market changes and maintain a competitive edge. So next, I will go through the concept definition for real-time data. So we can use WebSocket. The WebSocket can be used to realize real-time communication and data sharing between nodes in the link. For data visualization, Tableau combines data crunching with beautiful graphs, so we can consider to use Tableau and its dashboard to display the data. For analysis, prediction, and the recommendations, of course, for this purpose, we need machine learning uh, to do a prediction and recommendations for suppliers and clients. So for the cross-functional workflow orchestration, Microsoft Dynamics 365 automation software is the great choice for us. And the blockchain backed immutability and trust is for data safe, like I just mentioned before. Solution scalability that I told before. So the next step is engineering development stage. So for this stage, I will start with database selection. So that's the most important part in our system since everything is, around the data. So uh, since I have decided to integrate WebSocket for real-time communication, I need to determine which types of data need real-time updates and how frequently. After choosing the communication protocol, the next step is selecting a database to manage data. Database design is uh, inevitable in system design, and the database design is inspirable from discussion of SQL versus NoSQL. SQL is a programming language for managing RDBS, which is Relational Data Stream Management System. Usually, when people talk about SQL database, they are referring to relational database. Relational database are relatively mainstream, not only in traditional industry such as banking system, but also in today's large online services. So, relational database store structured data. The data logically exists in the form of a two-dimensional table of rows and columns, with each column representing attributes of data and each row representing a data entity. Relational databases have many advantages. It's such as easy to understand because there's a two-dimensional tables are very close to the way we logically understand the world. Very easy to maintain, mature community, stable service, stable data, high consistency, read and write in real time. Also, it's very flexible. SQL language is used to join tables. Relational database, of course, also have a number of disadvantages, such as high concurrent, like read and write performance low. To ensure high consistency, log compromises read and write performance. Table structure changes are costly. Modifying the table structure may make some database services unavailable. So the last thing is horizontal scaling is more difficult. Cross-server join, distributed transactions, etc. need to be addressed. So the relational database was born in the 1970s. The time have changed, and many assumptions that were still valid at that time have now changed, such as the cost of hard disk is no longer the bottleneck, restricting data storage, and the reading and writing of massive data has become the standard configuration of today's application. This provided the ground of development of NoSQL. Uh, NoSQL is also called non-SQL, non-relational, and sometimes not only SQL. NoSQL database logically provide different storage than two-dimensional tables. The advantage of NoSQL is to provide the more suitable database solution for modern applications, like horizontal scaling, the need of support massive read and write, data replication and partition, so higher ability at the expense of some consistency, promote denom- uh, denormalization, the use of cheap hard disk space to improve query performance. Um, but there are also some several disadvantages of NoSQL. NoSQL has weak consistency support. Most NoSQL databases tend to sacrifice consistency to enhance availability, and then it doesn't support join, and it has a neural community. So a relational database supports ACID, which is a top adversity, consistency, isolation, and duration. In the other hand, NoSQL adopts a looser model base, which is basically available soft state eventual consistency. From a practical point of view, I need to consider whether ACID is necessary for the application scenarios I face. For example, banking application must guarantee ACID, otherwise some money may be used twice, right? So for example, social software doesn't need to guarantee ACID because a status update for all users to read several seconds of time doesn't affect the use of. So for those applications that need to guarantee ACID, I can prioritize SQL. Conversely, NoSQL can be given priority. So it is worth noting that with the development of NoSQL in recent years, many NoSQL databases are getting better and better at supporting distributed ACID, such as MongoDB and DynamoDB. Um, it will take time to see, but it is conceivable that ACID will no longer be the pursuit of relational database. Sometimes our application contains very structured data that can be simply put into a two-dimensional table. Sometimes our application needs to store a key value pair, a graph, and article. In the former, I can use SQL or NoSQL, while in the latter, I prioritize NoSQL and choose the appropriate type of NoSQL database to store the data. So here is the relational database architecture. You can see this is a two-dimensional table, right? So two features of a wide column store can be seen in the figure. It can be regarded as the two-dimension versions of key value store, such as the content column in the configure above contains HTML content with different timestamps. Column family is supported. For example, anchor column family is the figure above contains two websites named that contains CNN keywords. Bigtable is the ancestor of this type of database, and HBase and Cassandra are also representatives of this type, in which HBase provides stronger consistency than Cassandra. Document store stores data in the form of JSON, which makes its structure extremely flexible. And when I have additional information to store, I simply add the new information to JSON as a new key value pair. On top of JSON, the document store also supports additional indexes to speed up queries. The graph store is, as the name suggests, for modeling graphs. In the graph store, information is stored in the form of nodes and edges, where edges represents the relationships between nodes. This kind of database can implement queries that non-graph store database cannot easily implement, such as all paths with fixed edges between two nodes, as expressed in the figure. After I collected a variety of types of data, such as user addresses, I can do analysis, predictions, and recommendations based on user address, sales volume, time of place orders, and the number of merchandise returns, etc. I can use machine learning model like linear regression or gradient boosting to predict which items are at risk of stock outs or overstocking based on current trends and upcoming demand. Let's start with linear regression. Linear regression is a simple model that predicts continuous outcome based on one or more input features. Since I need to predict whether can whether an item will be overstocked or at risk of stock outs, it's uh, crucial to choose parameters that provide relevant information and have predictive power. So I decided to choose some sales data such as historical sales volume, sales growth rate, seasonal sales patterns. Also, I selected some inventory data such as current inventory level, previous inventory level, inventory turnover rate, reorder point. After the inputs are ready, I also assign automatic weight to each feature during the training process. In this project, I will focus on supply chain systems in the food sector. On February 24, 2021, President Biden issued Executive Order 14017 on American supply chains. One of these directions was for the Secretary of Agriculture to submit in 1 year a report to President that assesses the supply chains for the production of agricultural commodity and food products. This shows that the President attaches great importance to agriculture. So, multiple nodes involved in computation in the blockchain network participate in data calculation and recording and verify the validity of their information each other, which can not only carry out information anti-counter, but also provide a traceable path through the information chain. The transaction information of each block constitutes a complete list of transaction details, which cannot be tampered with to record the incomes and outs of each transaction. When the user has doubt about the value of a block, it can accurately and easily backtrack the transaction record and then distinguish the historical transaction record. The supply chain system digitally signs submission requests and uploads data to the blockchain, ensuring that the data is true and immutable. At the same time, combined with Internet of Things, big data, and other technology to open up whole process data channel on the chain, we will deliver the high quality agricultural products to people. So here we're gonna jump into the post-development stage. After we finish development our system, there's something we need to do. First is deploy our project online, and after deploy, we need monitoring and maintain our project. And also the most important is data management. So for security and scalability, I decided to deploy the supply chain management system on AWS. The infrastructure setup will include configuring resources such as EC2 instance, RDS database, S3 buckets, and networking components like VPC, security groups, and the load balancer. Since the supply chain management system is a distributed system, I will implement AWS Elastic load balancing to handle traffic distribution between the front end and back end. The purpose of integrating a load balancer is to manage incoming requests and distribute them across a pool of servers using various algorithms such as round robin, these connections, or IP hash. This approach ensures that no longer server becomes overloaded, leading to improved overall performance and efficiency. Once the project is deployed, I need to monitor performance and address any bugs or issues reported by users. I will implement logging within the software application to record operational information, including errors, warnings, informational messages, and debug data. Log4j will be used for this purpose, offering a flexible framework for logging messages to various destinations such as the console files and database. For data management, including backup and recovery, I will use AWS RDS automated backups. This will capture point-in-time snapshots of our database with data stored across multiple availability zones for redundancy. Additional GitHub will be used to maintain code backups, including configurations, files, and scripts for database and infrastructure setup. I will implement branching strategy to safeguard the production environment. Now we are at the system engineering challenges of the program that I met in this project. I would say visualization solution involves several key challenges. Data integration complexity requires overcoming technical barriers to integrating different data sources across the supply chain to ensure consistency and compatibility. This complexity requires powerful systems that can handle a variety of data formats. Visualization accuracy and interpretation require designing a dashboard that effectively translates complex real-time data into actionable insights, ensuring that visualizational accurately present data enable decision maker to interpret data quickly and make informed choice. Real-time response is difficult to implement in a dynamic supply chain environment. Minimize delays in data process and visual updates is critical. Support fast response to change data. The single node database cannot handle the QPS like queries per second in large industry systems, so the database cluster must be used to share the large number of QPS. How can I reasonably distribute this QPS as evenly and well as possible across every node in the cluster? In case a node fails, such as the data disk is damaged, what about data stored in it, just lost it? This it is obviously impossible. How to do a good job of data replic so as to avoid single point filter? First, the second point, in case a node fails, how to ensure that data is not lost? Just copy the same data to a different node. The famous HDFS, like Hadoop distributed file system, uses the three copy idea. The same data is stored in three different nodes. Once a node fails, it is immediately restored by the other two nodes, which is very fast, and the upper layer application are not aware of it. HDFS belongs to the Hadoop Big Data System, and how does the traditional relational SQL database guarantee the data reflect? I can implement master-slave architecture. MySQL adopts the write-ahead log idea. Any operation of the master node will be recorded in the form of a log and then notify the slave to read the log. Because log only append, not update, the slave can read logs incrementally according to the timestamp and then perform redundant data backup. Therefore, the slave data is slightly delayed compared with the master if the service delay requirements are not high, can be tolerated a certain extent. Generally, can choose to read from slave because there is only one master. Only one master. Once it is suspended, the slave will be promoted to be master. But in the process of promoting, it may lead to a small amount of data loss and inconsistency. In this lesson, I learned a deep understanding of supply chain, including how it works and what it is used for. Besides that, I also learned the software development life cycle, including planning, analysis, design, development, testing, deployment, and maintenance. In addition, I learned about the system design, including the section between SQL and NoSQL database, understanding their respective use case and features, and sharding and the consistent hashing algorithm of database. I also learned machine learning algorithm, including predictive model and data analysis by linear regression and gradient boosting. Additionally, I explored cloud server, particularly AWS, gaining insight into this infrastructure, various features, and benefits for scalable and reliable cloud computing. Through this project, I learned distributed system architecture, how to design and the implementation of systems that can handle large-scale data processing and user requests. Furthermore, I obtained hands-on experience with continuous integration and continuous deployment practices, learning how to automate and streamline deployment and development and deployment process for more efficient and reliable software delivery. Thank you.